Good day, everyone. My name is Anthony Nathaniel, and today I'm so glad to introduce my new course on Global Education Zone, which is named Crash Secondary School Mathematics. So this is a Crash Secondary School Mathematics or High School Mathematics course, and in this course, starting from the first episode, which is today, we're starting from a revision of the junior secondary school work before we go formally into the senior secondary school work. So if you are an SS1, SS2, SS3, or you are trying to take your WAEC or GCE or any terminal examinations, this course is for you. Whether you are taking a WAEC or GCE or NECO, just name it. As long as you are around you are close to high school, you are close to high school education, you just finished high school education, you want to polish your mathematics, or you are about to enter into secondary school and you want to understand your topics, so this course is for you. So stay tuned, and if possible download the whole playlist so that you can be able to enjoy the entire content. So thank you. Now today we'll be starting from a revision of junior secondary school work. Now junior secondary school work will be divided into broadly four aspects, which is number and numeration. I'll call the first aspect number and numeration. Numbers and numeration. I'll call the second aspect algebra. I'll call the third aspect geometry and mensuration. Just call it geometry. And I'll call the last aspect statistics and probability. Statistics. Now, out of each of these sections, I'll be dealing with some questions. So I'll use those questions to explain and help you to brush through what you've covered. So for under number and numeration, let's see what we can do. Let's start from expressing 324 as a product of its prime factors. As a product of factors, and hence find its square root. Now, under number and numeration, the first question I'm taking is express 324 as a product of factors and find its square root. Now, when time you're asked to express as a product of the factors, what that means is that you are expressing 324 as a product of different numbers, and there's a technique for that. Just draw a straight line, a straight vertical line, draw a horizontal line, a smaller horizontal line, and then put that 324 above that horizontal line. Then you begin to cut it down. What that means is begin to divide it by its factors. So first of all, obviously 324 is divisible by 2. Let's use 2. 2 in 3 is 1, remainder 1. 2 in 12 is 6. 2 in 4 is 2. That's 162. 2 can still go in 162. 2 in 16 is 8. 2 in 2 is 1. 2 in 8 is not possible. So let's try 3. 3 in 81. 3 in 8 is 2. Remainder 2, right? Let's carry the 2 to the unit place value. So that becomes 21. 3 in 21 is 7. So next, what can go in 21 again? Let's use 3. 3 can go in 21. 3 in 21 is 3 in 21. Yes, I made a mistake here. Yes. 3 in 21, rather 27. Pardon. 3 in 27 is 9. Then 3 can still go in 9, right? 3 in 9 again is 3. 3 in 3 is 1. So obviously it looks like we've exhausted the factors. So we can now express them as products of one another. So we multiply them. So that means 324, if we were to condense them back into the original number, we'll be multiplying. The opposite of division is multiplication. So when you want to do the reverse, when you divided a number into its components and you want to get back the number, what you do is you multiply. When you subtract, the opposite of subtraction is addition, the opposite of addition is subtraction. Then likewise, the opposite of multiplication is division, the opposite of division is multiplication. I always tell my students that. Now 2 times 2 times 3 times 3 times 3 times 3. So this would be our answer. So 324 is equivalent or equal to 2 times 2 times 3 times 3 times 3 times 3. Now, if you were to express this as a product of factors, this would be the answer, and that is what we are asked to do. But let me take this a step further. What if we want to express this in terms of powers? Let's express this as product of its factors in powers. So what that means is you are going to look at the numbers you are multiplying. We are multiplying 2 by 2, 2 times 2. We are multiplying 3 times 3, 2 times 2 times 3 times 3 times 3. Let's group the 2's together. Let's put the brackets. This is 2 and 2, and this is 3, 3, 3, 3. 3. There are 4 3's, and there are 2 2's. Now, how many 2's are there? We have the number 2, right? How many 2's? There are 2 2's. So that's the number of 2's will be the power of the 2. So 2 raised by 2 times 3. Then how many 3's are here? 1, 2, 3, 4. There are 4 3's. So that will be the power. So that's 4 is the power. 3 raised by 4. So if you were to express this in terms of powers, it will be 2 raised by 2 times 3 raised by 4. So this is just a polishing of that. Then now we are asked to look for the square root. Now the square root is simply when you have doubles of a number, when you multiply a number, similar numbers, and you take one and you leave one. That is simply what the square root means. So for example, if we have 2 2's here, you can just take one and discard the other. That will leave only one. Then when you have 4 2's and you want to share it, that is what square root means. Square root is simply a sharing and division of powers by 2. So if I divide the powers of this by 2, I would get the square root of this number. So 3 raised by 4. When I divide that power, the power is 4, right? When I divide that 4 by 2, I get 2. So that's 3 raised by 2. That would be 2 times 3 raised by 2. 3 raised by 2 is 3 times 3. So the power means in 2 places. 3 raised by 2 means 3 in 2 places. 3 times 3 is 9. So 2 times 9 is 18. So at the end of the day, we've successfully decomposed 324 into a product of its factors, and we've also went further to express those factors in terms of their powers, and then lastly we'll be able to finally evaluate the square root of 324 as 18. So that is one example as a revision on number and numeration. Then moving on to the next section, let's talk about algebraic processes. Now this is a big part because most of mathematics is algebra, and algebra is basically the interrelationship between numbers and alphabet. So in algebra, that's when you begin to see 2x. So if I write 2x on the board, what would that mean to you? So 2x means you are multiplying 2 by x. That's what it means. So 2x will mean 2 times x. And that would simply mean you are multiplying 2 with an unknown number called x. In mathematics, we represent our unknowns as alphabets. Most especially, we use mix of the number x, y. We mix of p, q, r, s, t, x, y. So algebra is simply divided into algebraic expressions and algebraic equations. So this is an algebraic expression, 2x. If I write 3x minus 2, is also an algebraic expression. Now you might also have seen this in your junior school, where they say multiply a number by 3 and subtract 2 from the result. So what that means is you are multiplying a number by 3 and subtracting 2 from the result. What is that number? We don't know the number, right? So let's call it x. In mathematics, anytime you are not given a number, you will call it an alphabet. For me, my favorite is x. For you, yours can be z. Who knows? Now, they said multiply a number by 3. Okay, let me change the question. Let's say divide a number by 3 and subtract 2 from the result. So that number, let's call it x. So x, we are dividing x by 3. So that would be x divided by 3, and then I said and subtract 2 from the result. So now what this x divided by 3, we have to subtract 2 from it. So let's enclose it in brackets. So that's to show that it has its own product. Then we subtract 2 from it. That will be x divided by 3 is what? X over 3. Then minus 2. So that is the algebraic expression of this. So and then moving on to algebraic equations. Algebraic equations is basically a group of numbers that have an equals to sign. So an equals sign is a sign that a sign that denotes equality in mathematics. So it's represented by this equals to. So I'm very sure you would have heard or seen of that before. So next, let me talk a little bit more about algebraic equations. Let me give an equation and let's solve that in step-by-step process. Now, there are different types of equations. There are linear equations, there are exponential equations, there are quadratic equations, there are polynomials. Now, these equations, they are characterized based on their powers and based on what they are multiplied by. So linear equations have only x and it has the unknown raised to the power of 1. So what that means is that when you see your x, there won't be any number on top of your x or your y or any alphabet you choose. So that is known as a linear equation. But whenever you are seeing something like 2 on top of the x squared, that is no longer a linear equation. That is now a quadratic equation. A quadratic equation is an equation that has the highest power of the unknown as 2. Now a cubic equation is an equation that has the highest power of the unknown as 3. So I hope you are following in this revision class. Let me give an example of a linear equation and we are going to solve for our unknown. Now let me express the equation as this. Let's say 3 times of okay, let's say 5 times of a number, or rather let's say if we subtract 2 from 5 times a number, we multiply the result by 3, we will get 11 times the number. What is the number? So what I've just said is a word problem. Now it's a mathematical equation, but I decided to put it in English so that you can see that not just mathematics is what you need to know whenever you want to understand mathematics. You also need to be able to understand English. Now I said when we subtract 2 from 5 times a number, what is the number? Let's call it x. So 5 times a number, that will be 5 times x. And in mathematics, 5 times x is 5x. So when we subtract 2 from 5 times a number, that will be, subtraction is minus, then 2. And then we multiply the result by 3. So let's put it in brackets. So anytime you want to perform an operation, a mathematical operation on a result, always remember to put it in brackets. So that result will multiply by 3. So that 3 will be outside the brackets. 3. So when we subtract 2 from 5 times a number and we multiply the result by 3, we will get. So if you say we will get, or if you see anything like is equals to, so you make use of your equals to sign, or you say we will get 11 times the number. That's 11 times x. That's also known as 11x. So basically what this question is asking us to do is simply it's asking us to solve this equation. This is the equation here. 3 open bracket 5x minus 2 close bracket is equals to 11x. So what's the first thing we do? Now in mathematics there is a method that we call BODMAS. BODMAS. It's just a mnemonic for the order of operations of algebra or algebraic equations and expressions. So what that means is the B stands for your bracket. Now what that is telling you that whenever you see an algebraic equation like this, the first thing you are supposed to do is your bracket. The first thing you are supposed to evaluate is your bracket. Now if there's anything you can do in your bracket, you should do it. For now, there's nothing for us to do in the bracket because there are no like terms. So a like term is a term that can add each other, can subtract each other, and they can be simplified. But they are not like terms simply because this 5x, this 5 has an x, whereas this 2 does not have an x, so they are not like terms. But if it was 5x minus 2x, we would just say 3x. But now it is 5x minus 2, so they are unlike terms. So that means for this bracket, we don't have anything to do. So off, do we have any off? Now, there's no off. Do we have a division? We don't have a division. Next, we have m. BODMAS. M is multiplication. Do we have a multiplication? Can you see a multiplication here? Now, in secondary school, you will be seeing things like this, whereas you won't make use of your multiplication sign, but you make use of just the attachment of the number to the bracket. So whenever you see a number before a bracket like this, so 3 open brackets 5x minus 2, what that means is telling you is that this is 3 times. That will be 3 times open brackets 5x minus 2. So when they omit the time, the multiplication symbol, it doesn't mean it is absent. It just means it's another way of writing 3 times open bracket 5x minus 2. So what you do now is you open the bracket. Now we've gotten to where we can do now. What we can do, we can open this bracket. That will be, let's still put the right hand side 11x. Now the left hand side of your equation is your left hand side, the right hand side is your right hand side. Now when you are opening your bracket, you are going to multiply the number outside by every number inside. So, or rather every term inside. Now the first term, we have 2 terms inside the bracket, 5x and minus 2. So the term outside is 3, right? Let's multiply 3 times the first term is 3 times 5x. That's 3 times 5x. Let's close bracket. Now you make use of the sign. The sign connecting them is minus. Let's put the minus. That's 3 times 2 is 6 is equals to 11x. So continuing, let's say 3 times 5x is 3 times 5 is 15, and put your x. 15x minus 6 is equals to 11x. Now let's go on to another stage of this equation. What we are going to do here is we are simply going to be collecting like terms. And what are like terms? Like terms are simply terms that can be added and subtracted. Look at this, 15x minus 6 is equals to 11x. Now the like terms here are 15x and 11x because they are both products of x. They are both terms of x. So what we'll do is we are going to collect them on the left hand side. So what that means is that we are going to move this 11x over to the left hand side so that it can be added to or subtracted from 15x. So that will be 15x minus 11x. Now this minus 6 is an unlike term, so we'll move it to the other side. So when we take it to the right hand side, it will be 6. So note that anytime you change the side of a term in mathematics, you are also changing the sign. So when you change the side, you change the sign. So when we change 11x up to the right hand to the left hand side, it turns to minus 11x. When we change minus 6 to the right, it turns to 6. So your minus changes to plus, your plus changes to minus. Now 15x minus 11x is what? That's 4x. So all you need to do is just 15 minus 11, 4, and then put your x. 4x is equals to 6. Now we've gotten to a stage where we can easily perform the last operation, which is division. So one time you have 4x is equals to 6, like this. You have a number 4x is equals to 6. Now anytime you have a coefficient beside your unknown, the first thing you need to do is you divide both sides of the equation by that coefficient. So the coefficient of our unknown, that means the coefficient of x is 4. So what that means is that the number beside x is 4x. So we are dividing both sides by 4. That will be divided by 4, divided by 4. 4 cancel 4, that will leave x. Now 6 divided by 4 is, we can cut that down. So what that means is we are going to cut it down by the numbers that can go into the numerator and the denominator. So the numerator is the number that is above and the denominator is the number that is below. Now the numerator is 6 and the denominator is 4. So when you are trying to simplify a fraction, this is known as a fraction. Any number that has a numerator and a denominator is called a fraction. Now anytime you are trying to simplify a fraction, what you do is you are going to look for any number that can go in both the denominator and the numerator. Let me repeat myself. You are looking for a number that can go in both the denominator and the numerator. So the denominator is the number down and the numerator is the number above. Now, what number can divide both 4 and 6? So, can you guess it? I guess you're right. 2, right? 2 can go in 4 and 2 can go in 6. Because in your multiplication table, you have 2 times 1, 2. 2 times 2, 4. So, 4 is on the 2 multiplication table. And then when you go further, 2 times 3 is 6. 6 is also on the multiplication table. So, that's 6 and 4. They are both factors of 2. So, let's go on. 2, how many times can you see 2 in 4? That's 2 times 1, 2 times 2, 4. So 2 times, that's 2. How many times can you see 6 in 2? That's 2 times 1, 2 times 2, 4, 2 times 3, 6. So you can see 6 3 times. So we've basically simplified the fraction by cutting it down, and we've gotten what? 3 over 2. Now this 3 over 2 is our answer, and in mathematics there are different forms you can express your answer. You can express it in fraction, you can express it in decimal, you can express it in mixed fraction. If we were to convert this to decimal, we'll be dividing 3 by 2. So what that means is, how many times can you see 3 in 2? Sorry, how many times can you see 2 in 3? Only once. That would be 1. Remainder 1. So how many times can you see 1 in 2 in 1? That would be possible. So let's add 0 to that one. That will be 10. How many times can you see 2 in 10? That's 5. So we'll put a point. So anytime you add a 0, you put a point. That's 1.5. So 3 over 2 is also known as 1.5. Now, I hope with this step by step and extremely simplified calculation and solving, I've been able to show that algebraic equation and algebraic expression is just a as simple as ABC. Moving on, let's move on to the next section. And I hope you are enjoying this video. Please don't forget to like, share, and subscribe so that you can encourage me to continue providing educational content like this. Thank you. Now, the next section is geometry. So I'll have to clean the board for that. Let's move on to geometry. So what is geometry? Geometry is simply the part of mathematics that talks about those shapes. Now we are not writing now. In mathematics, the part of maths that involves drawing, that involves graphs, that involves all those triangles, squares, rectangles, cubes, all those things you can see every day, the things you can see, that's geometry. And apart from geometry, we also have what is known as trigonometry. Trigonometry is also part of geometry, and I will be talking about them together. In your junior school, you should have covered geometry or trigonometry, and if you haven't, don't worry, we'll do that in this video, in this basic video. So let's move on. So we'll start from the fundamentals of geometry. So what is the fundamentals of geometry? Geometry is simply the study of shapes in mathematics, and trigonometry is simply the study of angles and shapes. So that is why they are linked together. Now let me draw a shape. This is a triangle, right? Now in geometry, we have what is known as the area of a shape, and we have what is known as the perimeter of a shape. Now in this triangle, before we talk about those, look at this. We have 3 sides. Triangle, that's 3 angles. 3 sides, 3 angles. So this triangle has 3 sides. 1, 2, 3. Now these 3 sides, they have their length, and that is their magnitude. Now a magnitude of length is the magnitude, how long something is. So from here to here is the length of that side. So if we parameter want to call it 5, assuming this is 5 and this is 6 and this is 7. Now you might see in mathematics, they might ask you, what is the perimeter of this shape? Now the perimeter, don't be put off by that bogus grammar. The perimeter simply means what is the sum of the length of its sides. So coming again is the sum of the length of its side. So what that means is you add the length of each of the side of this shape. So you add 5 plus 7 plus 6. That is known as perimeter. Let's just call it P. Perimeter P is equals to, perimeter of a triangle is the sum of the length of each side. So if you have the first side as 5, you have 5, the second side you add plus, the second side is 6 plus 6, the last side is 7 plus 7. So everything will give us 5 plus 6 is 11, 11 plus 7 is 18. That will be 18. Now, before we write our final answer, you have to know what the unit is. Now, length is a quantity. Now, a unit is what is the language of that quantity? The language of length is in centimeter or meter. You've probably heard of that, right? And if you haven't, centimeter is a unit of measuring length. So most of the time in your mathematics, you will see that in centimeters, cm. So centimeters, when your question is in centimeters, your answer will also be in centimeters. So everything is 18 centimeters. So I hope you've gained something from that simple example. Now that is an example of perimeter of shapes. Now it doesn't just cover three sides, it also covers 4 sides. For example, if we have a rectangle is a shape with 4 sides like this. You've probably heard of it, you've probably seen it. Your window, it looks similar, right? It looks familiar. A window, a television, this looks like a TV. So anything that has 4 sides, 1, 2, 3, 4, is a rectangle. And more generally, we would call them quadrilaterals. So, but simply just call it a rectangle. Now for this rectangle, there are different properties of rectangle, but we won't be going into those details today. So, but imagine we have the length of rectangle. If we have the top to be 7 and the bottom to be 5, so what would be the length? What would be the total length of this what would be the perimeter of this rectangle? So what that means is that, I said the perimeter is the sum of all the sides. Now this has 4 sides, 1, 2, 3, 4. So we're adding all the length of all the 4 sides, but we only have this up and the side. What do? Can you guess? Well, what you do is you are going to assume the top is equal to the bottom. Why? Because in a rectangle, opposite sides are equal. So opposite means the sides that face each other. Now this side is facing this side, so they will be equal. This will be 7 and this will be 7. So that is one fundamental property of rectangles you shouldn't forget. So opposite sides of rectangle are equal. So, and that also applies in this side. So when this is 5, this will also be 5. So as such, our perimeter will be what? The sum of all the sides. That would be 7 plus 5 plus 7 plus 5. That would be 7. 7 plus 5 is 12. 12 plus 7 is 19. 19 plus 5 is 24. That would be 24 centimeters. So our unit is centimeters again, centimeters again, centimeters again, centimeters. Now that is the perimeter of a rectangle and triangle. Now we've learned to this extent. Now let's take it a step further. Let's become advanced in this part. And when I say advanced, I don't mean difficult. Let's just take it a little bit formal. Now there's what's known as formulas. So no matter what education you've had before, a formula is basically a shortcut, just like a short way across. Instead of you having to formulate every side and add them together, there's a formula for this. And for this triangle we've calculated earlier, the formula for the perimeter of a triangle is A plus B plus C. That's if the sides are A, B and C. The sum of the sides will be A plus B plus C. For a rectangle, if the top is A and the side of the top is B, that would be the perimeter would be 2 open bracket A plus B close bracket. So that would be, this is for a triangle, this is for a rectangle. And let me give you this tip: for any shape that has 4 sides, this also goes for it. Anything that has 4 sides, you can also use you can sum all the sides to get the perimeter. But for a rectangle, you use a specific formula. Then we also have what's known as a square. A square is basically a special rectangle that has all its 4 sides equal. So for this square, it will be 4L. So since all the sides are equal, there's no B, everything is just L. That was 4L. Now that is the perimeter of 3 common shapes. Now perimeters, I will keep going on. Let's go on to trapezium. So trapezium, the formula for perimeter of trapezium is A plus B plus C plus D. So if the sides are A, B, C and D, you add every of the lengths, because the perimeter is the sum of the lengths. So having done that, let's move on to areas. For area of shapes, we have, for a triangle, the area of a triangle is given by 1/2 half base times height times height. So I will be giving an application of this now. Now if we have a triangle here, the distance from the top to the bottom is known as the height. So if I draw a line from the top to the bottom, and that line is vertical. So a vertical line is a line that is at 90 degrees to the base. So don't worry about those details, but just know that a height is a vertical line from the top to the bottom. Now that height, if we have it as 6 for example, and then we have the base is the bottom. That is the part of that rectangle that is resting on the floor. Now if we imagine this to be a three-dimensional figure, this will be the base, right? Now imagine we have this from here to here to be 8. So what will be the area? Now the formula says the formula for area of a triangle is half base times height. That will be what? 1/2 times, what's the base? The base is 8 times the height is 6. That's, now we want to cut it down now. So 1/2 times 8 times 6, that's 1/2 times 8 times 6 is 48. So 1/2 times 48 is simply 48/2. That's 2 in 48 is 24. So 24 centimeter square. So anytime you are computing area, always make sure you put a square. What that means is, anytime you multiply centimeter by centimeter, you get centimeter square. Centimeter by centimeter by centimeter, you get centimeter cube. And what that means is centimeter raised to the power of 3. So anytime you multiply similar terms and you have them in if you multiply similar terms, if you multiply it in if you have a term multiplied and it occurs twice, the power is 2. If it occurs thrice, its power is 3, and so on and so forth. So that is how we got this square. Let's go on to rectangle. The formula for area of a rectangle is given as length times breadth. That's LB. The formula for area of a square is L square, and the formula for area of a triangle is 1/2 A open bracket B plus C. So here, assuming this A is the vertical from top to the bottom, that will be the height. So the formula for rectangle is half the height, open your bracket, the top length plus the bottom length, close the bracket. So when you multiply half by the height, then by the sum of the top and the bottom lengths, you are getting the area of the trapezium. And don't forget, all your dimensions will always be squared, because it is area, and area involves the repetition of centimeter twice. That is why it's square. Now, with all this said and done in geometry, let's move on to trigonometry. Now, for trigonometry, I will be introducing what is known as trigonometric ratios. But before that, let's quickly have a quick snippet on one theorem that is used in solving triangles. Now let's go back to triangles. Now I will draw a special type of triangle now, a right angle triangle. Now for this right angle triangle, what this means is that one of the sides is vertical, and if the base is horizontal, then one of the sides is vertical. So that is a right angle between that vertical and the base. And the right angle is also known as a 90-degree angle. This is a 90-degree angle. So now, this triangle, there's a theorem that is known as Pythagoras theorem, which says that, let's call these points where these lines meet, let's call this point A, let's call this other point B, let's call it C. Because in geometry, we like naming our points where the lines meet. So those are the corners of the figures. Now, we want to express the length in terms of each other, and that is what Pythagoras theorem says. Pythagoras theorem was set up by an ancient mathematician known as Pythagoras. And Pythagoras simply said that anytime you have a right angle triangle like this, then the longest side, the square of the longest side, when you square the longest side, it will be equals to the sum of the square of the shorter side. Now let me explain that further. Now in a right angle triangle, the longest side is known as the hypotenuse. That is HY, PO, T, NU, SE. And that's the longest side. Then the other shorter sides, they are the opposite and the adjacent. So let's call this the opposite. Let's call this the adjacent. AD, J, C, and T. So what we're trying to say here is that in this triangle, if we compute the square of the hypotenuse, so that means the square of the hypotenuse square, will be equal to the sum of the squares of the opposite and adjacent. So that means the sum of, so that will be the square of the opposite square plus adjacent square. Let me give an example. If this is a right angle triangle, or let's use our initial triangle. Imagine the hypotenuse is 13, and then our opposite is 5. So what will be the adjacent? So think. Now remember, Pythagoras theorem says hypotenuse square is equal to the opposite square plus the adjacent square. So and then in this our triangle, our hypotenuse square is the hypotenuse square is from A to B. The length of the hypotenuse is A to B. That will be AB in geometry. AB square will be equals to, then the opposite square is from B to C. That will be BC square. Opposite square will be BC square. The adjacent is AC. So the square of the AC will be AC square. That will be plus AC square. Now we will now begin to solve for our unknowns. We'll first substitute. For the hypotenuse is 13, right? That will be 13 square will be equals to, our BC is the opposite, and that is 5. 5 square plus our AC is the adjacent, and it is the unknown. Now personally, I like calling my unknowns X. Let's call it X. You can also tell me in the description in the description of this video what's your favorite alphabet for your unknown. So you can let me know. You can comment on this video. I'll appreciate it a lot. So moving on. Now we now have what is known as an algebraic equation. Remember, some minutes ago in this video I talked about algebraic equations and algebraic expressions. Now this is an algebraic equation, and then this is x squared because A is x, AC is x, so AC square will be x squared. Now this is an equation of second order. So what that means is that the power of the unknown, which is this x, you don't know what it is. It's not a number, it's an alphabet, so it's known as an unknown. But these ones that are numbers are known as constants. So a number is a constant in algebraic equations, and an alphabet is an unknown. Now the power of that alphabet is known as the order of that equation. For this equation, this has a power of 2, so this our equation has an order of 2, and in other words, it is also a quadratic equation. So any equation that has an order of 2 is quadratic, but any equation that has an order of 1 is linear. So but we're looking for x here. Now let's collect the like terms. It's only x that has x. The rest are simply numbers. So let's collect the numbers on the left hand side, and let's collect the alphabet on the right hand side. So this number will move to the left hand side and will change to negative. That's 13 square minus 5 square will be x square. Now 13 square is 13 times 13, that's 169, minus 5 square is 25, that's 25, will be x square. So 169 minus 29 is 144. That will be x square. So when x square is 144, because if 144 is x square, that means x square is 144. You can change sides. So the right hand become the left and the left become the right. Is also possible, is correct. Now, anytime you have any equation raised to the power of 2 and you're looking for an unknown, so you do what is known as the square root. You look for the square root. So we will look for the square root of both sides. So what you do to the left hand side is what you do to the right hand side. So the reason why you look for square root is that square root nullifies square. So this square root will cancel the square and leave x behind. And then on the right hand side, the constant side, we are only looking for the square root of 144. So you can make use of your calculator, or if you know it, that will be 12. 12, and then your unit is centimeter. So 12 centimeter. So that is another aspect of geometry. So let's move on to trigonometry. Now in trigonometry, we have an equation, a formula in trigonometry, which is known as the tangent. We have the tangent, we have the sine, we have the cosine. So now these three things I've mentioned, the tangent, the sine, and the cosine, they also have to do with triangles. So triangles also have sines, cosines, and tangents. Now for example, if I have a right angle triangle, as I mentioned earlier, the longer side is the hypotenuse, right? So this is the hypotenuse. Then imagine we have an angle here. This is an angle. An angle is that point where you have two lines meeting. So the degree of rotation from one line to the other is also known as the angle. Now this angle, I didn't say this before, but the side facing the angle, that is this one, will be our opposite. And then the side not facing the angle will be our adjacent. then the side that is facing the right angle, which is also known as the hypotenuse. That's it here. So this hypotenuse is facing the right angle. So, and the side that faces the bigger angle, the biggest angle, is the biggest side. So without even telling you, in a triangle, the bigger the angle, the bigger the side. So if a side faces the biggest angle, it is going to be the biggest side. If a side of a triangle faces the smallest angle, it's going to be the smallest side. It's kind of like a direct relationship. Now, moving on to trigonometry. So there are some rules of trigonometry you need to know before we can proceed into this mathematics for secondary school or high school. Now, the first rule you need to know is also known as the sine, cosine, and tangent rule. In Nigeria, we also know it as SOH as well. What that means is your sine, SOH, CAH, TOA. In mathematics, we like mnemonics a lot. So here we are saying that the sine is equal to the opposite. SOH, O is opposite. Then you put divided by the hypotenuse. Your sine is opposite divided by hypotenuse. Then your cosine is adjacent divided by your hypotenuse. Then your tangent is opposite divided by your adjacent. Now, these are known as ratios. These are trigonometric ratios, and they are used to calculate for sides whenever you don't know them. For example, let me make use of one of these. For example, if we have a right angle triangle and we have this as 30 degree, so this will be our opposite, and then we have our hypotenuse as if we were given our hypotenuse as, let's say, 8. Yes, we're giving this as 8. Now we are looking for our opposite. So what would be our opposite? So you have to use any of these ratios. You can use opposite of hypotenuse is equal to sine. You can use adjacent of hypotenuse is equal to cos. You can use opposite of adjacent is equal to tan. So let me see. I would like to use sine. The reason I would like to use sine is because we have the hypotenuse here and we are looking for the opposite. So everything just falls in place. So but if I decide to use cosine has adjacent, and I have no business with adjacent here. So what I have business with, I'm looking for opposite and I have hypotenuse. So that's O and H. That coincides with SOH. That's sine. So now you say the sine of this angle, sine, the angle is 30 degrees. Sine 30 degrees will be equal to the opposite. The opposite is unknown, so let's call it x. Opposite over the hypotenuse. Hypotenuse is 8. Now we are going to cross multiply to get x will be equal to sine 30 times 8. Now, in order to calculate sine 30, you can turn to your logarithm table. You have the sine of angles here. So when you turn to your logarithm table, you look for your sine of angles. So I'm doing that now. Sine of angles. Now, in our sine of angles, you are looking for sine 30. You look for 30 degree. So 30 degree in sine of angles is sine 30. So here we have sine 30 is 0.5000. So those zeros don't matter. That's just 0.5. X is 0.5. Sine 30 is 0.5 multiplied by 8. That's 0.5 multiplied by 8. That would be 4. So x is 4 centimeters. So that's an example of how you can apply trigonometry to calculating the unknown length. And it's still similar. If you are given adjacent and if you are given hypotenuse and you are looking for adjacent, you make use of cos. So we'll be using cos 30 instead of sine 30. So depending on the side you have and the side you need. So just consider what side do I have and what side do I need. So that will determine whether you use sine or cos or tan, but it's still the same method. So whenever you've gotten it to this equation, to this linear equation, then you can now go further to make use of your algebraic processes, addition, subtraction, division, and multiplication to solve for your unknown. And your unknown is your alphabet. So we just solved for x. So that means our x is 4. So instead of x, we can just replace this by 4. We've successfully solved for x, that's 4 centimeters. So I hope you understand that part of trigonometry. Now moving on to the last part of our introductory revision class, which is on statistics and probability. Now statistics doesn't have much much on statistics. Statistics is basically just on mean. You've probably heard of that: mean, median, and mode. So now in statistics is basically the statistics. When you hear statistics, you just know that it has to do with calculations, right? Calculations, statistics has to do with when you add things, or when you sum things up, when you evaluate, all those things that have to do with accounting and economics. But now in mathematics, statistics in our own way has to do with our measures of central tendency, our measures of range or deviation, measures of central tendency, and then we also have probability. Now I'll talk about those three in a moment. Now, measures of central tendency, there are three in numbers. So your measure of central tendency is your mean, your median, and your mode. And your mean is basically when you add all your numbers and divide by the number of numbers. So what that means is your mean is basically the summation of your numbers. So let's call it summation of x. If your numbers are unknowns like x over the number n. So for example, if we have a group of numbers, if we have a data like 2, if we have the number of people that knocked at your door in a week. So in a week has 7 days. So for example, maybe we have 2 knocked on Sunday, 3 knocked on Monday, 4 knocked on Tuesday, 5 on Wednesday, 6 on Thursday. Okay. What else? Who else knocked? 11, 7, 8. And then let's say 2 knocked on Friday, and then finally 6 knocked on Saturday. So in a week that would be 1, 2, 3, 4, 5, 6, 7 days. Now I will be using this data to look for our mean. Now our mean is basically we add everything and divide by the number of data. So what's the sum of the data? That would be 2 plus 3 5, 5 plus 4 9, 9 plus 5 14, 14 plus 6 20, 20 plus 2 22, 22 plus 6 28. That would be 28 over. How many data do we have? We have 2, 3, 4, 5, 6, 8. That's 1, 2, 3, 4, 5, 6, 7. We have 7 different data. That would be 28 divided by 7. So that would be, at the end of the day, that would be 28 divided by 7 is 4. So our mean is 4. That's the summation of the numbers divided by the number of numbers, or rather summation of the sample over the numbers of the sample. So that's the mean. Then next we have the median. The median is basically when you arrange your data in order. You can arrange this in ascending order of magnitude, you can arrange it in descending order of magnitude, but the data that coincides at the middle is your median. Let me arrange this data now. What is the lowest? Starting from the lowest, we have start from 2, we have another 2, we have another 3, we have another 4, we have another 5, and we have another 6. We have another 6. So when we arrange this in order of magnitude, we'll be having 2, 2, 3, 4, 5, 6, 6. That's, we still have 7 data. So what is the middle data? So basically, in this 7 data, you are going to look for what will be at the middle. So if we take one at the left hand side, we take one at the right hand side. We take another at the left, take another at the right, take another at the left, take another at the right. So what is left behind? It's 4. So that means 4 is our median because it's at the middle. So there is no pair, it's only 1. So our median is 4. So lastly, we've talked about mean, we've talked about median. Let's talk about mode. Now your mode is your data that occurs for the most. Now in this data, we have 2 numbers that occur most. 2 occurs twice, but 3 occurs only once. 4 occurs once, 5 occurs once, 6 occurs twice. Now let me introduce you to what's known as a frequency table. Now the number of times a data occurs is known as a frequency table. Now let's construct a frequency table. You just note the number. Let's call this a value. the values and then the frequency. Now if I draw a table, the value I will have the value of 2, we have value 3, we have value 4, we have value 5, we have value 6. So the frequency of 2 is the number of times 2 appears, that will be 1, 2. 2 appears twice. The frequency of 3 is the number of times 3 appears, that's once. The frequency of 4 is number of times 4 appears, that's 1. 5 is 1, 2. 6 is 2 because 6 appears twice on our table. So now the data with the highest frequency is the mode. Now you can see that 2 has 2 and then 6 also has 2. So we have 2 modes here. So this is also known as a bimodal data. So when your data has 2 modes, it's called a bimodal data. So our mode is 2 and 6. Why? Because they have the highest frequencies. So this is a frequency table that you will often be seeing in your statistics in your secondary school or high school mathematics career. Now, moving on to the last section of this video, let's move on to probability. So probability is basically the chance of an event happening, and what that means is probability has to do with when you have an event. The probability is basically the number of times that event occurs divided by the total number of occurrences. So for example, if I say in a school there are 4 boys and there are 6 girls. Now if there are 4 boys and there are 6 girls, so the total number of students in the school will be 10, right? Now in these 4 boys and 6 girls, they said if I were to enter into that school blindfolded, it's a new school, it's just opened, it doesn't have many students, just 10 students, and those students are in the classroom, and I should enter into the classroom blindfolded, and then I were to point at one of those students. I don't know whether it's a boy or a girl. Now what is the probability that I would point at a boy? Now what this question is trying to tell us is that what is the probability of picking or pointing at a boy? And what that means is the number of occurrences of that event you are looking for. Now in simple terms, what that means is that probability of boy will be equal to the number of boys divided by the total number of people in the school. That's S. So how many boys do we have? We have 4 boys divided by total number of pupils in the school with 10. That's 4 divided by 10. And if we were to convert this to fraction, that would be 0.4. And you could also cut it down to 2/5. So that is the basics of probability. Now the reason why I'm touching the basics of all these parts of basic mathematics is that you will need to understand this before you can proceed with this course. So thank you for watching.